about the different types of the plastic and how we can using different methodologies to manufacture the plastic products. So that the plastic, that the main problem that the Earth is actually facing is the plastic, but we still have some uh, research about how to minimize or recycle the plastic. And actually, I have another project which is going to be run this summer about how to use the plastic to build the construction material. That's mean we are going to save the energy due to the insulation. At the same time, we're going to recycle the plastic. So instead of leaving to be decay for maybe 100,000 of years in the dump yard, you can simply recycle it and leave it inside within the building envelope and let it decay for the 100,000 of years. Okay, so once again, the topic we're going to talk about today is going to be the plastic shaping processes. So to understand the plastic shaping process at the beginning, we need to understand what the plastic is. Usually the plastic is called the polymers. That means it consists of mers connected together to have the plastic thing. So the plastic is a material which is going to be semi-synthetic solid, and the monomers of the plastics are either going to be natural, like the rubber, we get it from the tree, or the synthetic organic compounds like the thermoplastic, which we can get it from the oil. The specification of the plastic is going to be the poor conductors for the heat and the electricity, so we can use them as an insulator. Also, they are insoluble in water, and thus we can use it, for example, like the plastic bottles or the containers, or even as a part of the ships or the submarines. The problem we have with the plastic is inflammable, and this is one of the main problems that actually holding me from using it widely as construction material. Do not corrode and rust, and that's why we can use them as a coating to protect the metals, for example. The plastic can be heated or molded into any shape and size to make the variety of the things. If you take a look around you now, in 5 seconds, you will count at least 10 products around you which using the plastic, including your clothes. So because of this specification,
yes. Why is it being inflammable stopping it from being used widely?
Sorry, I didn't get that.
On the last slide, you said that it's inflammable, and you said that's a bad thing. Why is that?
Now, just imagine. Now, I know that most of the clothes we have today is fireproof somehow, but in the old days, if you are sitting near the heater, and actually I saw something similar to that. If you're sitting near the heater and you're wearing the plastic, well, they call it the dealing at that time, it may ignite at any seconds while you're wearing the thing. Just imagine you're wearing a shirt, and because you're standing there, a heater, and boom, it will get the ignition point. Yeah.
Oh, so you mean so you meant it was flammable?
Yeah, it's flammable.
Oh, okay. All right.
Okay. So because thank you very much. Because of this specification, we have some advantage for the plastic and disadvantages. So the plastic is light in weight. That's why they are widely used in many of the products. Chemically resistant, can easily be shaped. Durable material after they've been shaped. Easy to color by adding some additives. Thermally insulating, the acoustically insulating, the electrically insulating, and also it can be used for the energy saving. The disadvantage are going to be the indestructible compounds that can be last for 100 or even millions of years. Even if they're going to be melted, sometimes it's going to be melted, the compound gas that's going to be given off is going to be very harmful to the health and the environment and the weakness of the ozone layer, as you know. That's why they're having the plan to reduce the depending on the plastic. Most of the plastic is usually made from the oil, and the world is going to be gradually running out of the oil. We're going to have a problem with the plastic. Now, the fact is the plastic usually going to be able to withstand the health to a certain level, And also this will lead to its being recognized as an important material in the aerospace technology. Now, when we talk about the space station, something about 60 to 70% of this station is made of plastic. Also, the plastic can be used as a fuel boosters from the rocket and even for the cars and the space shuttle and so on. So the plastic can be classified mainly into three different categories. The first one is the thermoplastic. The other one is going to be the thermosets. And the third one is going to be the elastomers. Thermoplastic is almost every plastic we have around us. The one that when again to heat up is going to be change the phase gradually, of course, from the solid to the liquid. And thus we can shape it, leave it to cool down, and thus we're going to have the final shape. The other type is the thermoset, which are going to be on the opposite way. It's going to be solid when they're going to be heated up. An example for that is the epoxy. So usually it's going to have a chemical process to make it liquid, and at the chemical stability is going to be liquid. When it's going to be mixed with the other agents or with the catalyst, it's going to have a chemical reaction and start to release some fumes, and thus it's going to start to solidify until it's going to have the final shape. And the third part is the elastomers, which we note as the rubber. And in this one is going to be unlike the other plastics, is going to be elastic, not plastic one. Okay, and of course, the application of the rubbers can be the tires, the footwears, the medical gloves, and so on. The elastomers can be natural, and this comes from the trees, rubber tree, and it also can come from the as an oil product. So if we can show that in this chart, what will be the types of different plastics and what will be the starting form for the manufacturing and the different methods of the manufacturing. So you can see that we have the TP, meaning the thermoplastic, is the elastomers, which is the rubber. The TS is the thermosets. So you can see that we have different manufacturing process we're going to go through this lecture, like the extrusion, the injection molding, the rotational molding, the structural form, the compression molding, the transfer molding, the casting foam molding, and we're going to talk about all these processes in the next slides. So we start first with the thermoplastic, which we said that the polymer melts to the liquid form at higher temperature. Its important properties for the polymer melts are going to be first the viscosity. The second one is going to be the viscoelasticity. So as a definition, viscosity is the fluid properties that relates to the shear stresses and to the shear rate during the flow. Usually, when we do as you can see from these two charts, when we do the processing on the thermoplastic, we would like to have lower viscosity, which is going to be desirable in most of the plastic manufacturing processes because this will let the plastic to flow through the mold. Something like when you increase the temperature of the metal to a higher temperature to have the lower viscosity for the metal. Usually the higher pressures will increase the shear rate and decrease the viscosity. So usually we have the injection molding when we do the process. And of course, if I'm going to heat up the plastic, I'm going to decrease the viscosity because it's going to be more soluble. For the viscoelasticity is a combination of both the viscosity and the elasticity. For example, if I'm going to have the die sole, as you can see here. So the hollow plastic simply going to be expand when it's going to be exiting the die opening, as you can see here. That's simply because it's going to have some memory of the shape before the entering of the die. Okay, so I think that's clear the difference between the viscosity and viscoelasticity of the plastic. Usually, the classification of the thermoplastic shaping processes can be listed as the extruded products with the constant cross section. And this is very popular uh, way to manufacture all the plastic. Most of the pellets we're using to another manufacturing process of the plastic is made first from the extrusion process. And once again, we talked about the extrusion process in the metal. The metal is not going to be much different, but the only way is how we are going to melt the plastic before we send it through the die, and then later, of course, we have to cut it. Also, we can do the thermoplastic as a continuous sheet and films. We can do the blow molding like the bottles and jars, continuous filaments like the fibers and the fibers we use in the textile manufacturing. The molded parts are going to be mostly solid shape. We can also have the hollow molded parts with relatively thin walls, and like the one we're using actually in, for example, making the pipes. And also we can have it as disc parts made of the foam sheet and films. And we can do it with the simple process of the casting. Just pour it in the mold and leave it to solidify, or it can be injected in molding. And also we can have it as a formed products. So all these processes, we're going to talk about them step by step in a short way, as I mentioned earlier. We don't give you the whole details. And if you would like to understand more about a certain manufacturing process, you will need to read further. And this is a part of the self-learning we try to push you toward. So this will be the first process, which is the extrusion process. So I think that you dealt with these parts through your life. Like, for example, we have the pipes. We can have the section. We use it for the paper holders, like this one. Okay. So the process is going to be very simple. We need to heat up the plastic or the elastomers by using the heat, and then we're going to force it through the die. Usually, the cross section of the part is going to be similar to the die opening. So the extruded part is going to be later cooled down, either by the exposing to the air by using the fan, or simply sometimes we need to immerse it inside the water. Then the extruded part is going to be coiled or cut to the desired length before we're going to use it. So you can see that typical product we can have in this photo is going to be the solid rods. And we can, this solid rod, we can have it as a pipe, tubing pipes, channels, and window frames, and so on. Usually the same process can be used to the coating of the electrical wires or the cables, and also it can be used for the simple melters for the injection molding and the blow molding, and we're going to describe this process soon. To start the process of the molting of the plastic and force it through the die, we're going to use the extrusion machine. So in this extrusion machine, we're going to have the hooper where we're going to put the plastic or the recycled plastic with a certain percentage. Usually the startup material is going to be called the pellets. It's going to look like the small cutted cylindrical shapes. And we're going to run it through the barrel. The barrel will have the conveyor, screw conveyor, and you can see actually the screw conveyor section is going to be different. The diameter is going to be increased toward the end, and this simply to do a certain calculation for the increasing of the pressure at the end of the barrel. So to do the heating up, the screw will rotate. We're going to have multiple heaters above the barrel, and this will cause the melting of the plastic gradually. So you can see that we have the feed section, the melt section, and the melt pumping section. We're going to have the lower viscosity at this range. Usually we're going to have thermocouples to turn off the heaters if the temperature is going to be too high. That's mainly for two reasons. We don't want it to be too soluble. The second reason is going to be we need to take the temperature to the ignition point. The movement of the screw conveyor will simply going to force the plastic to be sent through the die outlet. Usually, we need to have a screen, and we're going to talk about the screen in the video we're going to watch next. After we send it out, we need to cool it down rapidly, and this can be either by using the air fan, or sometime in the water if the temperatures need to go too high. So the next video is going to show you how the plastic is going
Now
to
let's
be
look at the inside.
how the plastic is going to be traveled through the extrusion die. So this video is going to talk about the process, the shape of the screw, the use of the screen at the end, and why we need to use it. Okay, I'll try to lower the voice a little bit and play the video again.
Side of an extruder to see how it works. The plastic raw material in this hopper travels by gravity to the feed throat and drops onto the rotating screw. The rotation of the screw conveys the plastic forward through the heated barrel. As the plastic is conveyed forward along the screw, the channel depth decreases, forcing the plastic through a smaller area. The combination of compression and screw rotation causes friction, which generates heat. This is called shear heating. This heat, along with the heat from the barrel heating system, melts the plastic. By the time the plastic is conveyed to the end of the screw, it should be well mixed and at a proper temperature and pressure needed by the die. The plastic is called a melt at this stage. Beyond the screw, there can be a screen pack. The screen pack is a set of wire mesh filters that the plastic must flow through. The screens are typically from 20 to 100 mesh, which indicates the wires per inch. The screen pack is supported by a breaker plate, which is a sturdy metal plate with many holes for the plastic to pass through. The screen pack filters contaminants from the melt. The screen pack must be set in place with a coarsest screen next to the breaker plate, so each screen can support a finer one. Otherwise, the pressure difference may break the contaminating the product and possibly doing permanent damage to the die.
So I think that's the process is quite clear. And we're going to go further for the different types of the die opening we can have. Now, most of the cases, and actually the simplest design is going to be if I'm going to have a solid cross section. The dies can be simple, a hole, or it can be something like, for example, like a square shape or rectangular shape, and then we're going to inject the plastic through it and get it out of the other side as a solid cross-sectional. More complicated methods, like I would like to make up pipes or tubes. So in that case, I'm going to have the mandrel, which is going to blow the air in the middle. And this way, I'm going to cause to have the hollow cross-sectional shape. Of course, this shape, by the way, can be a C shape to have the C cross-section, can be the I shape, different cross sections we can have. But if we're going to go to the stage, we would like to have the hollow parts. We need to use the mandrel with the air pressurized in the middle. Actually, this is a better look for that, for the making of the plastic tubes and the pipe extrusion. So we're going to have the mandrel sending the air. The shape of the die opening is going to be spider legs, 3 different parts. Otherwise, we're not going to be able to hold it in the middle. So the hot plastic, when it's going to leave the spider legs, they're going to be connected together. With the help of the air, they're going to be stay hollow in the middle cross-sectional. Sometimes we can have the co-extrusion for the producing of the bottles, and in that case, we're going to have two extruders, and we're going to have the mandrel in the middle. Once again, it's going to send the air and going to have the paration, The brush will be cut to a certain size, and we're going to send it later for the blow-up machine to make the bottles. The same process can be used instead of using the mandrel and the air. We can put the copper wire in the middle. So the copper wire in the middle and it's going to pass through the outlet of the die, and this will cause the plastic to be coating the wire. So usually the speed of can be go up to 50 meters per second, which is going to be very high productive. Usually the wire will be go through a water to be cooled down immediately after the coating process. The same extrusion process also can be used to make the thin polymer films, as you can see here. So the mandrel actually going to send the air at higher rate, and this will cause the blown of the tube instead of having the thick walled tube. And then we're going to run it through the guided rolls and start to wind it up to have the, it's going to be actually very thin films. Okay, so once again, it's the same thing like making a tube, but this tube is going to be a thin walled tube. And the process is going to be different. We're going to run vertically, horizontal is going to run vertically. Now, the difference between the film and the sheet is going to be mainly the thickness. Usually the film thickness is going to be something below 0.5 millimeters, while the sheet we're talking about a thickness from 0.5 millimeter to 12.5 millimeters. The film, as you know, can be used for the packaging, and it can be used for the stock of the photographic films in the old days. I think they still use it somehow. Also to make the pool covers and the irrigation dish linears. Where for the sheet, we can use it for the flat window glazing and for the thermoforming stocks. The materials for the polymer sheets and the film usually going to be all the thermoplastic polymers. While for the sheet film and the production processes, mostly widely used processes are going to be the continuous, the high production operations. The process include the slit-die extrusion of the sheet and the film, the blown film extrusion process, something similar to the one we saw earlier, and the calendering. So let's take a look about the different processes we can use for the sheet and the film production processes and the following one. So the first operation is to be the slit-die. So this is a machine we have for the slit-die, and something going to use the narrow slit-die opening, like we can have here between these two layers. Okay, to produce the plastic sheet and the films by the conventional extrusion. So we send from one side, as you can see here, this is the top view. Okay, and it's going to be distributed over this thin slit, narrow slit, and we're going to have the extruded film on from the other side. The slit can be up from 3 meter wide and as narrow as 0.4 millimeter thickness. Many results of the non-uniform thickness through the width due to the polymers melt status is going to be changes, as you can see here. So usually we're going to have thicker at the ends and thinner at the middle. So usually we need to trim the unwanted part. The edges of the film usually again must be trimmed because the thickness at the edge is going to be higher, as we mentioned earlier. The other operation, which is the blown film, similar to the one we saw earlier, the blown film extrusion process, which is comprised of the extrusion and the blowing to produce the tube of the thin films. The process sequence mainly is going to be extrusion of the tube, as you can see here. The air will be assisting of blowing up the things. Okay, it's going to be drawn. The tube is going to be drawn upward while it's still molten and expanded by the air inflated into the thin films through the die. As the usually is air going to blow into the tube to maintain the uniform film thickness and the tube diameter from the exit till it's going to be winded up on the reel.
So, sir,
Yes.
where does the air go out there?
You mean at the end?
Yeah, when
Yeah,
it's all
actually,
like
yeah. Actually, I'm going to force it to leave from here.
from the very end. Oh,
Yeah, from the end.
oh, neat. Cool.
Yeah, it's not going. Don't worry, it's not going to be trapped here. It's going to
Okay.
find the escape when you're going to press it. Okay, because just remember, even till the end is going to be acquired hot, and we can make the things. Actually, do you know what do we use this process?
No.
The plastic bags.
Like the Woolies ones.
Yeah, all the plastic bag actually made by this operation. Okay. Now the other process is So the other process is going to be the calendering. The calendering is something like we do the rolling for the plastic. Again, to have the feedstock quite viscous, but it's not going to be liquid. It's going to be passed through a series of the rolls to reduce the thickness to the desired gauge. This process is going to have very expensive equipment and higher production rate. The process is not going to be as usual notes for the good surface finishing and the high gauge accuracy because we control the thickness during the rolling process. Typical material is going to be the rubber or the rubbery thermoplastics such as the plasticized PVC material. The products can be the PVC floor covering, the shower curtains, the vinyl tablecloths, the pool linears, and the inflatable toys. Now, another important product is the fiber and the filament products. You have it everywhere on the textile of your chair, your clothes. Even when they call the cotton, actually, most of them are not natural cotton. We're using the fibers. So difference between the fibers and the filament is the fiber is usually going to be long, thin strand. The length is going to be at least 100 times of its cross section. While for the filaments is a fiber of a continuous length. The applications are going to be mainly for the manufacturing of the textile. At the same time, it can be used for the reinforcing materials in the polymers and the composites. Now, can you give me an example of the polymer composites?
Bed sheets.
Sorry, I didn't hear that.
Bed sheets.
No. Now, do you ever found a faulty tire?
Is one nylon, sir?
Yeah. So the nylon tire, nylon actually, the tires have a multiple layers of fibers and filaments because this will give it the reinforcing. If we're going to have the rubber itself at higher temperature, it will simply expand it or even going to be teared. That's why if you're going to have a cross section of the tire, you will find inside a different types of reinforcing, including some of the fibers and the filaments, and also you can find some wires. The materials for the fibers and the filaments are, we can use natural fibers, which usually going to be 25% of the total market, where the wool production is much less than the cotton, and the cotton is even less than the natural, the fibers and the filaments. Also, we usually get used as synthetic fibers like this one to make the textile like that. Now, actually, technology is much advanced than it used to be back in the 70s. So that the 70s was very popular. If you take a look for some of the photos or video from the 70s, you can see all those shiny clothes were actually made of the fibers and the filaments of the plastic. But as I told you earlier, it wasn't that safe like what we have it today. And also the material is much more different, like the odor, and the old days when it was exposed to the sun, you can actually smell the plastic. So how we can make the fibers and the filaments? The main process is called the spinning operation. And this usually going to be used for the synthetic fibers. So the spinning is the extrusion of the polymers melt or solution through a spinnator. And then it's going to be drawn and winding into a bobbin, sorry. Okay, so simply the spinnator is going to do something like a sieve, but it's going to have a rotation at the same time. As you can see here, we can have the molten draw region, and then we're going to cool it down by the air, and we start to roll it until we're going to have the balloon take up at the end. The three variation we have depending on the polymer is going to be the melt spinning, we can have the dry spinning, and we can have the wet spinning. From the name, for the melt spinning, we're going to use the heat to make it liquid, and then we're going to run it through the spinners. So this will be the first operation, the principle of the melt spinning. We heat it up, and then we get run through the spinner, and then we're going to collect it at the end, cool it down by the air. The other operation is going to be the dry spinning, and the third one is going to be the wet spinning. The wet spinning, we're going to use a chemical to melt it down and roll it at the other side. So the dry spinning is similar to the melt spinning, but the starting polymer is going to be in solution, and the solvent can be separated by the evaporation. The first step is going to be the extrusion through the spirit. Usually it's going to be extrudable. It's going to be pulled through the heated chambers when removed for the solvents, leaving the polymers as a solid. Used for the filaments of the cellulose acetate and the acrylics. For the wet spinning, it's going to be similar to the melt spinning, but the polymer again is going to be in solution, and only the solvent is going to be non-volatiles. The other thing we're going to talk about is going to be a very popular manufacturing process for the plastic, which is the injection molding. And actually, if you take a look to the your phone, your laptop, most of the products we have around us, the TV set, all the case of these products are actually made by the injection molding. So in this process, we are going to melt the plastic. We are going to heat the mold itself to a certain temperature. Then also we need to cool it down later, of course. And it's going to be the polymer is going to be forced under higher pressure into the molding, and where it's going to be solidified, then where it's going to be removed. That's why you can see that we have these blue dots, which are actually the water channels to cool down the products. The process usually going to be used to produce the discrete components to the net shape. So we can use it directly after we are going to solidify it. I think that the typical timing for the solidification is going to be something between 10 seconds for the small parts, and maybe it can go for 30 or 45 seconds for the bigger parts. But if of course, we're going to make something like a thick wall, maybe it's going to take even 1 minute or even going to be 5 minutes to be cooled down. The mold usually going to contain a multiple cavities, so I'm not going to make one part each time I'm going to inject the plastics. I can make a multiple moldings are going to be used for each cycle. The different types can be made by the injection molding, like it can be a complex and the intricate shapes are going to be possible, but we still have some limitation, which is the capability to fabricate the mold, which is going to have the cavity have the same geometry as the part. Because if I get to make it too complicated, I'm not going to be able to take off the part from the mold. The part size can be as small as 50 grams up to 25 kilograms, like what we have, for example, in the bumpers for the cars. The injection molding usually economical, only for the larger production in quantities due to the high cost of the mold. The mold can cost me, for example, $100,000, and I'm not going to use it to make 20 parts. At least I need to use something about 500,000 parts. So in that case, each part will cost me something about 20 cents or even less. The polymers we can use for the injection moldings usually going to be thermoplastics, but sometimes some of the thermosets and the elastomers also can be used in the injection molding. But in that case, I need to do some modifications. So the thermoset is not going to be solidified before it's going to fill the cavities. The machinery actually is going to be very simple. I'm going to use the same device I used earlier in the extrusion. But instead of having the parts solidify after leaving the die, actually I'm going to inject the mold with the plastic. Those steps are going to be very easy. I'm going to close down the die. Of course, this operation is melting the plastic. So at the minute I'm going to close the die, the rotating screw will start to rotate, fill the plastic within the mold. When I'm going to have a certain amount of pressure, it will hold, and then it's going to be retreat back on the other direction, open the mold, take the part off, and repeat the process. So once again, the injection molding machine is going to be the general one, usually going to have two principal components. First is going to be the injection unit, which is everything we can see from this line to the left, while on the other side I have the clamping unit, which is going to have the clamping cylinder, quite high pressure using the hydraulic, which is going to keep the mold closed while I applying the pressure due to the injection of the plastic inside it. The injection unit of the molding machine consists of the barrel and the screw, and of course we need some heaters. Difference is that the screw we have in the injection molding, different from the extrusion, is that it can rotate in both directions. So it's going to act as a ram here to inject the molten plastic into the mold. No return valve near the tip of the screw prevent the melts from following backward into the screw reeds, and later the cycle ram retract to its former position. The clamping unit function usually going to be holding the halves, which are going to be pressurized from inside, keep the mold closed during the injection by applying the clamping force, and open and close the mold at the appropriate times in the molding cycles. Usually this time is going to be set to a certain amount, and this usually going to be known by the trial and error, because I'm not going to be able to check if the part has been solidified or not. I mean, I cannot see through the mold itself. So once again, this step is going to be close the mold, start the rotation, send the polymer melts inside the mold. The no return valve will stop the material from coming back. And later, again, to open the mold, retrieve the thing on the other sides, and then we start the operation multiple times. Okay. So the mold itself is going to consist of, it can be classified in different types, like the cold runner with the two-plate mold. And this usually going to be solidified plastic is going to be run into the channels that connect the mold cavity to end. The barrel must be always trimmed, as you can see here. This is the only part we will need to use. We can use the cold runner with 3 plates, where the run system is going to be separated from the parts when the mold is going to be open. And we have the third type, which is going to be the hot runner mold, where it's going to be usually more expensive because it's going to have multiple parts, no gates, no runners or spurs attached to the mold parts, and the molten plastic is going to be kept in the hold heated runner plates, and usually this will have a shorter cycle time. And this is another type of the plastic. We call it the foam injection molding. And I think that you saw this one. Usually the main part we can, the classical part we can describe as a foam injection plastic is the dashboard of your car. The cover of the dashboard usually is used by using the foam injected plastic. So it's type of thermoplastic. It's made by the using of the foam injection molding, and it's a process of the molding of the thermoplastic parts that possesses a dense outer thicker skin at the top, surrounding a lightweight foam in the center. The part usually going to have the high stiffness to the weight ratio, and this can be produced either by introducing the gas to the molten plastic injection unit or by mixing the gas, producing ingredients with the starting pellets at the beginning. Usually a small amount of the melt is going to be injected to the mold, then it's going to be expand and fill the cavity. The foam contacting the cold mold is going to create this skin, thick skin, while the one inside is going to have the bubbly shape of the structure of foam core. The injection molding of the thermosets is also possible, as we mentioned earlier, but we need to do some modification for the machines. So this modification, as we mentioned earlier, should avoid the premature cross-linking of the thermoset polymers. That means it's not going to be solidified while we still working on it at this stage, or we trying to fill the mold. So to do that, we need to have a shorter length for the barrel. The temperature is going to be low because the temperature is going to be harden the part instead of making soluble. The melt is going to be injected to the heated mold, and the cross-linking occurs to cure the plastic. The curing usually is going to be the most time-consuming process in this operation, because it's not going to be solidified at the same rate as the thermosets. The thermoplastic. The mold after the solidification is going to be open and the part is going to be removed. We can have another method, which is the reaction injection molding. Now, in that case, we are not going to use the heat. We are going to use only the chemical reaction. We are going to use the two highly reactive liquid ingredients are going to be mixed and immediately injected into the mold cavity where the chemical reaction leading to the solidification. The reaction injection molding usually, well, actually, did anyone send a message here? Oh, no, not you, sorry. Okay, so usually the reaction injection molding, what usually they call the RIM, was actually developed for the polyurethane, the material, yes, to produce the large automotive bumpers and the fenders. And the parts usually have the foam internal structure surrounded by the dense outer skin, as we mentioned earlier. Also, we can use the same process because we're using the chemical reaction to manufacture the epoxy parts. The blow molding is a molding process in which the air pressure is going to be used to inflate the solid plastic into a mold cavity. And that's actually what we use to make the water bottles. So usually it's going to be important for making of the one-piece hollow plastic parts with the thin walls. and have very high production rate, because the times of these items is going to be thin. Sorry, time of silicon is going to be too fast because the parts are thin walled. To accomplish the process, we need to do it in 2 steps. First, the fabrication of the starting tubes, which called the parison, and we can do the parison by doing the extrusion process. And the second one is going to be the inflation of the tube to desired final shape, and this by sending the higher pressure inside the parison, of course at high temperature, and then it's going to be inflating and attached to the wall of the mold. The forming the parison is going to be accomplished by either the extrusion process or the injection molding. The materials usually are going to be thermoplastics. I think the next video is going to show you the process of making starting from the parison until we're going to have the final product. So we saw that the parison has been inserted inside the mold. The plunger, which is the metal part, has pushed the parison to make it longer. Then we send the air. So the air expanded the parison to make it fill the cavity of the mold, attached actually to the walls of the mold. So the process is going to be very simple, and actually this one is going to be a continuous extrusion process. So this machine is going to be connected to an extrusion machine. We're going to send the tube die at high temperature inside the 2 sides of the mold. The mold will be closed, and thus we're going to seal the parison from the top, and we're going to send the air. Usually we're going to use the the plunger to do the work. So it's going to be sending the air in the middle, and this will process, making the process having the constant pressure in the middle. Okay, after we having the solidification process, the 2 sides of the mold will be open and we get the product out. And then the process will be continuously done until we're going to manufacture the desired amount of the bottles every day. So this is the classical extrusion blow molding. The other one is similar to, this is the simulation process for it. Okay. We can use the, what we call the stretching. I think I missed something here. This is the classical one. This is something injection blow molding. Well, in the injection blow molding, we are going to have the parison is going to be injected directly into the mold. Then we're going to take it to the other mold, which is going to be the blow mold, and the plunger is going to be sending the air into the parison and make the shape of the bottle, open it, and then repeat once again. So the first step is going to be the injection molding of the parison, then the blow molding, and we keep repeat the same process continuously. So that will be the parison we made by the injection molding, and this is the final product. This is just an example. So usually the stretch blow molding, we're going to use a plunger, as we mentioned, once again, to make the length of the parison longer before we're going to send the air through. Many of the water tanks you're using every day, the plastic one, actually the big one, is made by the rotational moldings. This approach will use the gravity inside the rotating mold to produce the hollow part shapes. It's alternative to the blow molding for the larger parts. and it's going to have, of course, more complex external geometries. The problem with this operation is the low production rate, because the times for the solidification is going to be longer. Mostly it's used for the thermoplastics, but also can be used for the thermosets and the elastomers for certain applications. The products we can have from rotational molding is going to be the boat hulls, the sandboxes, the buyers, the garbage cans, the large containers, and the storage tanks. And the steps are going to be very simple. We're going to have the indexing table. We do the load and the unload of the materials and the one of the stations, the heat and the rotate of the mold, and then we need to cool down the mold before we can take the part out. So this can be done at the usually it's going to be 3 stations, and we can show a video for that. I think I have a video somewhere, but I cannot find it now on my computers. Now, the other process for the making of the plastic is called the compression molding. And in this one, we're not going to have the closed mold. It's going to be 2 half molds, and we're going to put the charge in between them, compress it, and force it to fill the shape of the molds after closing. So it's going to be something similar to what we had in the powder metrology. It's widely used for the thermosetting in plastic. It's used for the rubber and the tires and the polymers matrix composite parts. The molding compounds available in the several forms, which can be powders or the pellets, can be liquids, or it can be the preforms. The amount of the charging we're going to add inside should be controlled to obtain the repeatable consistency in the molded products. The molds we can use for the compression molding usually is going to be simpler than the injection molding because it's going to be open shape. No spurs and no runners systems in the compression molding to be used. The process itself is generally limited to the simpler parts geometries due to the lower flow capabilities of the thermoset materials. The molds must be heated usually by the electrical resistance, the steam, or the hot oil circulation to increase the rate of the solidification or the curing. The materials and the products we can use going to be the phenolics, the melamines, the urethylformaldehydes, the epoxies, and the elastomers. Typical compression molded products going to be the electrical plugs, the sockets, the housings, the boat handling, and the dinnerware plates. Now, actually, you can check the quality of one of the things we can see every day, which are the port handling. Have you ever thought about that this plastic has been made from different material because we use it at higher temperature, but it's never melt? And also you can check something. If this part is going to be broken, you cannot use the, for example, the super glue to weld them because it's super glue only used for the thermoplastic, never used for the thermoset material. Okay.
Why is that so?
Why?
Yeah.
The MERS type is different. The chemical properties are different.
Oh, okay. Cool.
Okay. The types of the molds can be different. We can use the transfer molding, which can be classified into the port transfer molding and the plunger transfer molding. So usually the thermoset charge is going to be loaded into the chamber immediately ahead of the mold cavity, as you can see here. And where it's going to be heated, the pressure then is going to be applied to force the soft polymers into the heated mold, where it's going to be cured. The 2 types, we said that we have the port transfer moldings, where the charge is going to be injected from the port here, forced to go through the vertical spur, to fill the cavity of the mold. After the solidification, the plunger will send it out, and we're going to have the color spur to be removed as a waste material, and this is the molded part we're going to use. The other type is going to be the plunger transfer molding. And in this case, we're going to put the materials in the cavity. Okay, we are going to use the plunger to force it to go through the cavities, or we're going to have the horizontal runners to fill the cavities of the parts. Now, the color will be cutted, and this will be the final parts on the sides. We can have two different types, which is going to be the compression and the transfer moldings. And both the process, usually again to have the scrub is going to be reduced and need to be removed, and we call it the cull. Usually the thermoset plastics cannot be recovered. So everything we're going to say is going to be a scrap. It's non-recycled material. The transfer moldings is capable of molding more intricate parts, shapes than the compression moldings, but usually not going to be intricate as the injection molding shapes. Transfer molding is usually suited to molding with the inserts. And simply we can placing a metal or ceramic inserts in the cavity before the pressing. So we're going to press the thermoset material is going to have some reinforcement in the metal. Now, the other process is called the thermoforming. And I will be in the school on Friday. I'll try to make a video for the thermoforming process, so that we have some videos here. We have the machine upstairs, and we used to use it for some projects for the advanced manufacturing. But anyway, in this process, we're going to have this flat thermoplastic sheet or film. We're going to heat it up, and then we're going to deform it in the desired shape using the mold. The heating usually is going to be done by the radiant electrical heaters located either on the top or bottom or both sides of the starting plastic sheet or film. It's widely used in the packing of the products and the fabricate of the large items such as the bathtubs, the contoured skylights, and the internal door linears for the refrigerators. The materials usually going to be thermoplastics, only thermoplastics. The sheet is sheet for the thermosetting or the isomers polymers have already been cross-linked and cannot be softened by the reheating. The application for thermoforming is using, if we're going to use the thin films, it's going to be for the blister packs and the skin packs for the packaging community products such as the cosmetics, the toiletries, small tools, and the fasteners. Also, if I can use the thicker sheet stock, I can do the boat hulls, I can do the shower stalls, and edifying displays and designs. So the pros, once again, by the way, we have negative and positive shaping. This is the negative type. So we're going to have the heaters. In this case, is going to be exposing the heat at the top of the plastic sheet until it's going to be quite flexible. We're going to put it at the top of the mold. This one is negative because we're going to empty this area from the air, and this will force due to the negative pressure we're going to have, will force the soft sheet or film to take the shape of the mold. After solidifying, we take it out. Usually we need to trim the width and use the final product. And this is an example of this process. You can see that we are going to have the heaters. In this case, it's going to be at the top or the bottom, and the sheet or the film is going to be in between the heaters. This is my mold, and that's how it's done. Now, most of the operation we saw here was different from the one we had in the previous slide. Now, what we have here once again was that the film is going to take the shape of the mold by suction. So, in the one we saw in the video, actually, the mold was forced inside the sheet first. Then we have the suction to make it take the shape of the mold. All the other operations were the positive, and this one is the negative. Okay. So we have negative molds and positive molds. So the one we see here is the positive one. So negative mold has the concave cavity, as in the previous years of the diagrams we saw. The positive mold have the convex shapes like the one we saw in this video and the videos before. For positive mold, the heated sheet is going to be dragged over the convex form, and the negative or positive pressure force the plastic against the mold surface to take the final shape. Okay, now once again, we have the positive and the negative different types of the, this is positive one. Maybe this process is very rare to be used, but actually is in use. Most of the metal you can get from some of the tourist places which have the parts inside actually were made by the casting of the plastic. So simply we're going to have the liquid resin to be poured into the mold using the gravity to fill the mold cavity, and it's going to get hardened within the time. In this case, we can use either thermoplastic or the thermosets. Thermoplastic, for example, is going to be the acrylic and the PVC. Thermosets can be the unsaturated polyesters and the epoxies. Usually the shape of the mold is going to be simple, unless if you like plan to destroy it after you fill it. For example, you can make it out of gypsum. You can actually, I saw a video once for that, and you can fill it with the multiple parts. You can fill it with the molten plastic like the any type of resin. Then you need to clean it later, but this is not going to give it a good surface finishing. Oh, one thing I forgot to talk about in the thermoforming, which is the mold itself. Now, anyone here have an idea about what the material we use to make the thermoform molds?
Metal.
Sorry?
Metal.
Metal? What type of the metal?
Aluminium.
Aluminium. Okay.
That one.
Now, usually the aluminium is going to be quite heavy mold, but it's going to last for a long time. And usually when you use it for thermoforming, they didn't show that in the previous videos, but actually we need to add some talc powder on it. So we're not going to have this stick in between both, especially if the shape is going to be quite complicated. If I'm going to use it to make less number of parts, then the old method usually was using the wood. So they cutting the wood on the milling machine to make a different shapes, and then they usually, because you know that the wood is going to have some porous, so and this will make the plastic to stuck on it. So usually they put some varnish at the top to give it the glossary shape. But this will be cracked from time to time due to the high temperature, and it needs to be recoated multiple times. The stainless steel is actually very rare to be used because it's not losing the heat very fast. The aluminum is good conductivity material for the heat, so it will absorb the heat from the sheet and make it cool down faster. Definitely I will take a photo for the mold I use for my heat exchanger, which was actually made of the aluminum, and actually took 2 days of machining when I did it. And because actually the details are too complicated, very small details, and it was still quite heavy, something about 12 kilograms. And at that time, we didn't have the thermoforming machine at the school, and I had to use the one they have in the design school at the UTS. And the mold was always stuck in the plastic because the amount of the powder was not enough, and then suddenly fell down and slammed against the machine. And the people was looking at me through the window. They thought again to destroy their machine. Okay, now the other type, which is very popular.
I mean, with the timber molds, it was very hard to get a vacuum on it. So you didn't
Yeah, it's too complicated. I will show you that the cavities were actually too small, something like the size of the wheat seed. It's too small. I mean, the geometry at the top was almost the size of the wheat seed. That's why it was always 100 of those on the surface, because I was making a heat exchanger with the corrugated face.
Oh, wow, nice.
I will show you a video for that later. Okay, now the other one is the polymer foam, and this actually not old technology. We are going to use a mixture of both the polymers and gas. And this will simply going to give the materials the lightweight because it's going to have air inside the porosity. Most common polymers forms are going to be the polystyrene, and also the other polymers can be in the natural rubber. The classification of the polymers forms are the elastomeric, and we have the flexible, and we have the rigid. The properties of it is going to have very low density, high strength per unit weight, good thermal insulation, and good energy absorbing qualities, and that's why they use it for the sport shoes. So for the extrusion of the polystyrene forms, usually it's going to be a thermoplastic polymers. The physical or the chemical blowing agent is going to be fed into the polymers melt near the die end of the extruder barrels. Thus, it's going to be mixed, and then it's going to be expanded, taking the shape of the mold, and then we can take it out, as you can see here. The molding process for the polystyrene forms usually is going to be by using the expandable foam moldings. And the products usually going to, for example, is going to be the hot beverage cups. The shaping of the polyethylene forms can be thermoset, the elastomers of the thermoplastic, which is going to be less common. The foam itself probably is going to be made in one-step process in which they're going to have the two liquids going to be mixed together and immediately fed into the mold or the other forms. The polymers is going to be synthesized and the polymer is going to be created at the same time. The shaping can be done by the spraying or it can be done by the pouring process. Okay, so the next step, the next section is going to be the processing of the polymers matrix, composites, and the rubbers. So I'd prefer that we take something about 8 minutes break. Then we are going to come back to this one. During that, we can ask some question about the major project. Okay, so I will stop the recording. We're going to have another half